Hi everyone, welcome to the Tech Master. Today I'm going to solve another problem, and the problem is the best time to buy and sell stock. So, what's the problem statement here? We are given an array of prices where the array contains the price of a stock on any given day. So, let's get into more details. So, if we look at the array contains 7, 1, 5, 3, 6, and 4. So these are the prices for a given stock on any day. So on the day one, the price is 7. On the day two, the price is 1. And on day three, the price is 5. And the same thing going forward. So what we need to do here. So the ask is to provide the maximum profit. So we are allowed to make only one transaction. And what one transaction mean here is that you can buy a stock on a single day, and then you can sell that stock in any coming future day. For example, if we buy the stock on day one, we can sell it on any upcoming day, day two, day three, day four, day five, day six. And if we buy the stock on day two, we can sell it on day three, day four, day five, day six. So if we buy the stock on day one with the price 7, so if we see in the array, there is the stock price is always lower than what we bought at. So we are not getting any profit here. But if we buy the stock on day two with price 1, and if we sell the stock on day three at price 5, then we will make a profit of 4. 5 minus 1, 4. So we are making a profit of 4. And if we sell the stock on day 4, 1 minus 3, or like 3 minus 1, we can say, and we will make a profit of 2. So what we need to do here, we can buy the stock on any given day, and we can sell the stock any day in future. So we need to maximize the profit, and we have to do only one transaction. And yeah, one transaction here means that we buy on any given day, and then we sell in any future day. So how can we solve this? So, one solution that's coming to my mind immediately is the brute force solution, where we where we where we buy the stock on any given day, and then we see like what all profits we are making if we sell the stock on any upcoming day. So let me get into more detail. For example, if I buy the stock on day one, so what I will do, I will check upcoming days. Like if I sell my stock on day two, day three, day four, day five, day six, then what all profit I'm making. So it's like I need to keep track of my maximum profit. So initially my maximum profit will be 0, because like if we are not able to make any profit, then the value that we will be returning will be 0. So here we do not make any profit. But if I buy the stock on day two, so I'll be buying the stock on price 1, and I can sell the stock on price 5, and then 3, and then 6 and 4. And if I see here the maximum profit I'll make if I buy it at price 1. I mean, in this case, when I buy on day 2, I'll be buying at price 1, and I can sell on day 2, 3, 4, 5, day 5. So I'll be making a profit of 5. But that will not stop here. Then I will see like if I buy my stock on day 3, what all profit I can make. Day 4, day 5. So I can go till day 5, because if I buy on day 6, I do not have any other option to sell. So there will not be any profit. So here, this is the brute force approach, where we buy the price on any given day, and then we check like what all profits we are making for that buy in the future day. So this can be solved with simple 2 for loops, and the time complexity will be big of n square. So here the time complexity will be big of n square. So so Can we make the solution better? Yes, we can do that. If we see here, we can buy the stock on any any given day, and then we can sell the stock in future. So if we look at uh, this constraint that we have got, uh, what I see clearly is that I need to buy my stock on the least price, and I need to sell the stock on the maximum price. So one thing that I clearly see is that we can keep track of minimum price. For example, uh, okay, let me go to the code part. So what we can do here. So initially, yeah, minimum buy, I'm taking it maximum integer value. So let's see what we will do. Yeah, so max profit will be 0 and current profit will be 0. So we will be iterating through the given price list. And one thing is that so initially the minimum price at which I'm trying to buy the product. So that's the minimum buy, and initially the first price will be assigned because like we have taken the maximum maximum value of any maximum value of integers. So initially the minimum y will be assigned with the price one. So the example that we took, I'll just put it here. So initially it will be assigned 7, and else what we will do, like if we already have the minimum price, what we will try to do, we will see like what profit we are making. So we will have some current profit, like uh, for example, initially 7 will be assigned to the minimum buy. So yeah, so minimum buy will be 7 initially, and then when we go to 1, we will see uh, that price I is less than minimum buy. So our minimum y will become 1, and now we are going to 5. So 5 is not less than 1. So our minimum y remains 1, and our current profit. So initially what happened? So current profit was 0. So now current profit will become 5 minus 1. So price is I, the 5, and minus minimum y, 5 minus 1. So our current profit is 1, and max profit is also, sorry, not 1, 4. Our current profit is 4 and max profit is 4. Now next we go to 3, but 1, 3 is not less than 1. So again the current profit will be 3 minus 1. So current profit will be 3 minus 1, that will be 2, and max profit will remain 4. And now we go to 6. Our current profit will become 6 minus 1. So 6 is also greater than 1. So we go to else block, and our current profit will become 5. So our current profit become 5, and our max profit also become 5. And now we go to 4. So again else block will execute, and 4 minus 1 equals to 3. So our current profit will be 3, but max profit remains 5. So our current profit equals to 3, and max profit equals to 5. and we return the max profit. So return max profit equals to 5. So if we look at this test case also, the output expected is 5. So let's run this solution that I have coded here. Yeah, so I'll just run it. Yeah, so these test cases are accepted. Let's submit. So our solution is accepted, and even it beats 99.91% users with Java, and even like memory wise it's good. And what's the time complexity here? So the time complexity will be because of that. Because like we are just iterating through the array once